Hello everyone, welcome back to Diksha Vedantu Foundation channel, and now I am going to discuss the physics of sample paper 5. So all the physics questions from the sample paper 5 we are going to discuss now, and if you have any doubts, any clarification that you might need, you can post that in the comment below. Also, to download the question paper, obviously you know that you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description. From there you can join the WhatsApp channel, download the question paper, see it for yourself, then you can match the question number and the solution for those questions, right? So without much delay, let's start with the sample paper. Let's see the question paper analysis. So we have 3 marks coming from 1 mark, that is 2 MCQ and 1 assertion and reason based question. Then we have 1 2 marker question, we have 3 3 marker questions, we have 1 5 marker, 1 4 marker as usual. So total marks coming out to be 23, I think. So generally 25 marks is allotted to physics, but this paper has only 23 marks, so 2 marks less for this paper. So let's start with section A, that is 1 marker question. The light enters from air to glass having refractive index 1.5. The speed of light in glass is. Very simple, easy, but still difficult question. We know that refractive index is given by speed of light in vacuum divided by speed of light in that particular medium, that is the refractive index. So speed of light in glass when it enters from air, so air basically means speed of light in vacuum, speed of light in air, in both cases this is C. If it is any other medium, then we have to know the speed of light in that particular medium, but it is not required here. So speed of light in glass is basically C divided by N. So C is basically 3 into 10 to the power of 8 meter per second divided by 1.5, right? So 1.5 means what you have to do, you have to cancel them, so you'll get 2 into 10 to the power of 8 meter per second, right? So the answer is this. Okay, be careful while answering, don't fall for the traps, specifically option A and option C. Okay, so this is the answer, easy question. Move on to the next question. For a convex mirror, the image distance V equals to 5 centimeter. Focal length F is 10 centimeter and height of the image is 7.5 centimeter. The correct representation according to the sign convention is. Very interesting question. So first it is given as convex. Okay, does not matter it is mirror or lens. Okay, as we said, for convex surfaces focal length will always be positive. Okay, so focal length will always be positive. That means from there we can see that focal length is given positive only for option B and option C. So out of them only one will be correct, right? Now convex mirror, we know that they form virtual images. Okay, so suppose what is the meaning of that? Convex mirror is there, so there is an object. Wherever you keep the object, it will always form a virtual image which will form behind the mirror, right? So again it will go in this way. So it will always form a virtual image. So virtual image means the image distance will always be positive because it on the right hand side of the mirror. In case of mirror, image distance will be positive. So don't be confused about mirror and lenses. Okay, so for mirror, the image distance will be positive, focal length will be definitely positive because it's a convex surface, and object distance is always positive, object height is always positive. Okay, so correct answer is option D. Okay, clear? In fact, even if you are not sure about V, you know that for convex surfaces focal length is positive and object height is always positive. So based on that combination also you can answer, okay, this is the only possible combination which is making sense. So V will be positive in this case, right? So even if you are not sure, you can answer it, but you have to be careful. This kind of questions are nowadays a common question, right? So let's move on to the assertion and reason based question. So what is assertion? Assertion says that one circuit with 15 ampere current rating is used for appliances such that geysers and air coolers. So current rating for air coolers, geysers, etc., they have a higher current rating, that is 15 ampere, which is correct. Okay, appliances with metallic body are connected to an earth wire with low resistance. Now this is also correct. Appliances with metallic body are connected to earth wire because in case there is some current leakage, okay, that extra current from the body, instead of electrocuting you, it will go directly to the ground, okay, giving it a low resistance path. So it will not come to you, it will directly go to the ground and it will save you from getting electrocuted. Now both statements are individually correct. Assertion is correct, reason is correct, but if you read them properly, there is no apparent reason between these two, assertion and reason, right? So even though they are correct, there is no link between them. So we can say both A and R are true, but R is not the correct explanation of A. Okay, so this is an operational point of view, that they require high current because they require to convert higher amount of energy, right? So for example, geysers, what they do, they heat up the water, right? So we know that I square RT from Joule's law of heating, the energy dissipated is I square RT. So higher the current, higher will be heat generated. Higher the heat generated, quickly the water will become hot. So that's why geysers use 15 ampere. Similarly, air coolers, they work on the reverse principle. Okay, so they also require higher amount of current so that it can work quickly, it can cool down the atmosphere quickly. So that is why they generally have a higher current rating. Okay, whereas this is also true, the devices like refrigerators, microwaves, okay, they always have a third connection, which is a ground line. That ground line prevents the metallic body from getting extra electricity. In case there is a leakage, that extra current will be converted, connected back to the ground, so without getting you electrocuted. So these are the reason, but there is no proper connection, so definitely it will be the option B. Now let's move on to the section B, 2-marker question. So give reasons for the following. Red traffic signals can be seen from a very long distance. So if you have seen that the danger sign, that traffic signal, when you are moving in a traffic, you may have seen that whenever there is a red sign, the car stops. Okay, whenever it gives you a green sign, the car starts moving, right? So why the red light is used for a danger sign? Some says that it is a color of blood, etc. So blood is maybe dangerous, it is a symbol of danger. So most of the danger signs, wherever you go, they are made of red, which is nothing to do with blood, which is nothing to do with violence. The main reason is that red light can be seen from a very distant part because it scatters less. Okay, it scatters least actually. So from the all visible light, red light scatters least. That's why it is visible from a long distance. That is why it is used as a traffic signal. Right? Stars appears to be slightly higher than their actual position. This is because of atmospheric refraction. Let's see exact answer that they prescribed in their answer sheet. Because this is a model question paper, so there is a standard answers to them as well. So let's understand that because red color light has the highest wavelength and least scattered, it is visible from a very far. So that is that part they have not mentioned. So this is the reason, but you have to also mention that is why they are visible from a long distance. Okay, so anything which scatters less, that means it is not moving away randomly, it is going straight. Okay, if you don't scatter from your path, that means you are going straight, right? So if you scatter away from your path, that means you are not reaching your destination. So if you want to score well in your board exam, then you have to keep your wavelength high, you show that you don't scatter, right? Your mind should not be scattered too much, it should be fixed. Now why stars appears higher than their actual position? So basically what is the meaning of that? Suppose you are seeing a star somewhere here, okay, that is actually not the position of the star is actually located slightly lower than that position, okay, in the sky. Okay, sky height is determined by higher it is, exactly top is the highest position, and slowly it moves in the both side, right? So if you are seeing a star somewhere, that means the star is actually not here, it is slightly lower towards the horizon. Okay, why it is happening? And it goes for both side of the sky, by the way. Okay, why it is happening? Because the optical density of atmospheric layer is more, so that light traveling from the space to the atmosphere bend towards the normal, and thus the position appears to be slightly raised. Okay, full marks for the label diagram. So if you just draw the labeled diagram, you get full marks. If you explain and with the diagram, that is fine, but if you just draw this label diagram, then also you will get a full marks. Okay, so what is that? Actual position of the star. Now light ray is bending, and it is reaching your eye, but our eye cannot track this bend path. It only follows the last thing, whatever is there. So for example, when you are in the classroom and you are disturbing to your friend, and your friend suddenly reacted to that and shouted on you, your teacher, whoever was teaching in the classroom, he didn't saw you, he saw your friend is shouting and he punished him, right? It happened to you either way of the things. Maybe you are the one who got punished because you are the last person who did something, right, reacted to something which was done by someone else, right? So our eyes are like that also, right? So that's why teachers don't see everything, so they see whatever is the last thing that is happening. So light ray is traveling like this, and when it reaches your eye, okay, our eye cannot track this curved path. It is only sees that as if the light is coming from the last straight path through which the light ray falling on your eye. So that is why the star appears slightly higher in the sky, right? Interesting. Now let's see the 3 marker questions. A 4 centimeter tall object is placed perpendicular to the principal axis of a convex lens of a focal length 20 centimeter. Okay, the distance of the object from the lens is 15 centimeters. So first of all, it's a convex lens. Okay, so convex lens means focal length is positive. Okay, focal length 20 centimeter. Focal length is positive. Height of the object is given 4 centimeter. So focal length is given 20 centimeter. The distance of the object from the lens is 15 centimeter. So this is the object distance u. U is also given. Find the nature, position, and the size of the image formed. Okay, so you have to, what you have to do? Find the nature, real, virtual, etc. Position, what is the exact value of v, and the size of the image formed. And there is a OR question as well. An object is placed at a distance of 60 centimeter from a concave lens. Now it is a concave lens. Okay, u is given 60 centimeter of focal length 30 centimeter. So now in this case focal length will be negative because it's a concave lens. For any concave surface, be it lens or be it mirror, it will be negative. For any convex surface, be it lens, be it mirror, it will be always positive. You have to remember that. Use lens formula to find the distance of the image from the lens. So that is basically you have to find v. Draw a ray diagram to justify your answer in part A. So you have to draw the ray diagram as usual. Okay, so 1 mark for this, 2 mark for this. In this case, nature 1, position 1, and size 1. So based on whatever question you choose, you have to answer. Both questions are similar. One is convex lens, one is concave lens. So let's find out. So we know that u is always negative no matter what. So u is negative. There will be some cases, there are some difficult cases where u can be positive, but that is not we are going to discuss here. So u is negative. Focal length for convex lens, as I said, is always positive. You have to find v. So use the lens equation, 1 by v minus 1 by u is equal to 1 by f, and then calculate, and you can find it to be minus 60. The mathematics is simple. I trust in you that you can do that. In case you are having trouble to find the mathematics, you can mention in the comment below. Now magnification is basically for a lens is given by v by u. Okay, now object height by image height is equal to V by U. So object height you can calculate. Object height is given 4, so you can calculate the image height to be 16 centimeter. Now what is the sign of V? So V, if you see, V is coming out to be negative. Negative V means, what is the meaning of negative V? Negative V means the image is formed on the same side as the object, right? So that means it's a virtual image. In case of lens, if image and object are on the same side, they are virtual, right? So image is formed is virtual, erect, okay, and magnified. Why erect? Because object height is positive, also the magnification is also positive. That means it must be a erect image, and magnified because you can see that initially it was 4 centimeter and now it is 16 centimeter. So definitely it's an magnified image. So if you answer this correctly, then you get full marks, full 3 marks. Okay, now they have said any two point is sufficient: virtual, erect, and magnified. Any two of them, nature of the image, they have asked you nature of the image. Okay, they have asked you the position of, this is the position, this is the position of the image, this is the height of the image, and property of the image, nature of the image. You have to mention at least 2 of them. Okay, virtual, erect, and magnified. If you write all 3, very good. Right, now we need to calculate the image distance. So in this case, image distance, so diminished image is formed, there is only one image pattern for concave lens, right? We know that. So the image, you can draw it. So this is the object passing through the, right, it passes like this. This is the easiest ray diagram in terms of drawing the ray diagram, because we know that concave lens always produces virtual images. So this is the virtual image, this is the object, say AB, this is A dash, B dash, right? So the V is coming out to be minus 20 centimeter. Okay, U was minus 60 centimeter, F was minus 30 centimeter, because for concave lens we know that the focal length is negative. So applying that, you can calculate V. The diminished image is formed on the same side as the object and a distance of 20 centimeter from the lens. This is the part, and this is the ray diagram. This is the ray diagram given here. Now, this is given here as well, right? This one also fine, looks fine. Same, only one type of ray diagram is possible for concave lens. A current of 10 ampere flows through a conductor. This is question number 32. Okay, let's see the question. A current of 10 ampere flows through a conductor for 2 minutes. So current of 10 ampere flows for 2 minutes. Okay. Calculate the amount of charge passing through the conductor. So if you have followed my formula problem, I told you current is basically Q by T. So from here we can see that Q is equal to I into T. So you have to convert it into charge. Now remember that 2 minutes is given. 2 minutes means 120 seconds. You have to convert it into SI unit, which is seconds. Then you can multiply it, right? So you can see that 120 second into 10, that is 1200 coulomb, right? The charge of an electron is 1.6 into 10 to the power of minus 19 coulomb. Then calculate the total number of electrons flowing through the conductor. Now this is slightly tricky. Okay, VI graph for conductor is as shown in the figure. What do you infer from this graph? So current and voltage graph is given. So as you can see, as the current increases, voltage also increases. So current and voltage are directly proportional to each other. So in other words, this is a ohmic conductor. So these are the things that we can infer. Let's see what is the answer they have given. So first question, given I is equal to 10 ampere, T is equal to 2 minutes, that is 120 second. So charge is basically 1200 coulomb. Okay, for that you get 0.5 marks. Okay, now Q is equal to Ne. So charge of one electron is 1.6 into 10 to the power of minus 19 coulomb. So one charge is 1.6 into 10 to the power of 19 coulomb. Now in your next class you will learn that charges are quantized. That means every charge is basically multiple of that charge, that is 1.6 into 10 to the power minus 19e, and then you can do that. Otherwise what you can do in this problem, so they have given you charge of one electron. So charge of one electron is given 1.6 into 10 to the power of minus 19 coulomb. This is charge of one electron. Suppose the charge consists of small n number of electrons. Okay, so this amount of charge consists of small n number of electrons. Now charge of one electron is this, charge of small n number of electron is n into e. So that is the total charge, that should be the total charge, that is Q is equal to Ne. So n equals to basically Q by E, right? So you have to divide it like this and you will get the very high number 7.5 into 10 to the power of 21 electrons. So very high number of electron is located in this amount of charge. Okay, as the graph is a straight line, so it is clear that graph V is proportional to I, hence the resistor of the conductor is constant and it's an ohmic conductor. So V is proportional to I, as I said, resistance is constant, obviously V is proportional to I. From Ohm's law we know that V is equal to IR, so R is equal to V by I, and also we can say that this is an ohmic conductor. Okay, that is also an inference that we can draw from the graph, right? Now 33, question number 33, draw the pattern of magnetic field lines around a current carrying solenoid. Mention two precautions that should be taken to avoid the overloading of domestic electric circuit. Easy question, this is the easiest question from all the three questions that we have seen. So the diagram we already know, this is like this. Okay, you have to just use your pencil and your drawing skill. If you are very poor at drawing skill, then you have to go back to the previous question, which is slightly tricky in my opinion. But if you can draw, this is the easiest question to draw. Okay, exactly, you don't need to draw the exact way, but it should be similar to this, right? Your solenoid should be clearly visible, the battery should be visible, the current should be visible. Okay, current is going in this direction, then the magnetic field lines will be in this direction. Okay, magnetic field lines will be in circular way here. So you have to be careful with the direction so that all the directions are matching inside this wire. Okay, so if you see that it is starting here, so after going here it is going in this same direction. Similarly here also it is going in the same direction. So every line is in the same direction, that you have to be careful about. In case you are showing that inside the solenoid the lines are going from left to right, but in the top part or bottom part you have showing the magnetic field lines is going in the opposite direction, then that will be considered as a mistake and marks will be deducted accordingly. So be careful when drawing this diagram. Okay, so diagram 1, direction of current, direction of field lines. Okay, as I mentioned, the direction of current and direction of field lines must be mentioned. Okay, so for diagram you get 1 mark, for direction of current you get 1 mark, 0.5 marks, sorry, and for direction of field lines you get 0.5 mark. Okay, so if you make any one of these mistakes, there will be 0.5 marks deduction in this case. Okay, so 2 marks only for drawing this diagram and 1 mark for writing the safety precautions. What are the safety precautions? You have to see that do not connect too many devices in the same socket. So if you are using socket, try to not to overload the socket so that the current rating exceeds and the socket gets burned. So that is one important thing. Secondly, do not connect faulty appliances in the socket. So if you are connecting a socket, means the 3-pin plug that we call, right? Socket means where we put that 3-pin plug into the holes. So that is a socket. Okay, and the 3 pins that you see is a plug. Okay, and the plug point where you put that plug is called socket. Okay, multiple high power consumption devices should not be connected to the same time. Okay, so multiple high power devices should not be connected at the same time, so that everyone is drawing high power, then there is a chance of overloading and burning. Okay, so these are the main things that you have to be careful about. Also, one more thing is that the power rating should match. So if the power rating of the device is say 15 ampere, or current rating, basically if the device says it works on a 15 ampere socket, and if you are entering it into a 5 ampere socket, there is a high chance there will be overloading. Okay, so you have to be careful about where you are inserting the socket. So whatever power current rating given for the device, that same power rating should be matched. So power rating or current rating, basically current rating of the device should match the current rating of the socket. Now if you can connect a 5 ampere rated device into a 15 ampere rated socket, that is fine, because the highest power rating for the device that it is going to consume is 5 ampere only. So 15 ampere socket may work for that, but you cannot apply a 15 ampere device, you cannot plug a 15 ampere device into a 5 ampere socket. So vice versa is not possible, right? So higher socket rating is higher, your device rating is lower, perfectly okay. But your device rating is higher and your socket rating is lower, that will not work. There will be a high chance of burning. In case this is a very common mistakes many people do even in our household appliances, so do try to avoid that, right? Next is section D, 5 marker question. A person is unable to see objects distinctly placed within 75 centimeter from his eyes. Name the defect of the vision the person is suffering from. So within means from closer to your eye till 75 centimeter he is not able to see anything, so he cannot see basically close objects. Okay, so basically he is suffering from farsightedness. Okay, he can see far objects clearly, but near objects he cannot see. Okay, what is the name of that vision problem? That problem is called farsightedness or hypermetropia. Okay, name the defect of the vision person is suffering from. List 2 possible causes. There are 2 possible causes. Calculate the power of the lens needed to correct this defect. Assume that the near point of the normal eye is 25 centimeters. So this is another hint that near point has receded. Near point of human eye is receded to from 25 to 75 centimeter. So this is what they are saying. Now there is a OR question to this as well. Why is a normal eye not able to see clearly the objects placed closer than 25 centimeter? Okay, why the near point is 25 centimeter? What happens if it is placed very close to your eye? With the help of a diagram, show recombination of the spectrum of white light. We discussed this in our last class also. List 2 essential conditions for observing a rainbow. So this is a mixed bag of questions. Okay, one question from human eye portion, one question is from the dispersion portion, and one portion from the rainbow portion. So all from the same chapter, but it is a mixed bag question, right? Let's see. So hypermetropia or long-sightedness or far-sightedness. Okay, so basically hypermetropia, far-sightedness means he can see. There is a trick to that. So if you are not able to see closer objects but you can see distant objects, then it is called far-sightedness. If you are seeing closer objects clearly but you cannot see distant object clearly, then that is called near-sightedness. Sightedness means you can see nearby objects, you cannot see far objects. So that is why it is called near-sightedness. That means you can see nearby objects clearly, you cannot see distant objects. Okay. So 2 possible causes is that curvature of the eye lens decreases. So curvature of eye lens decreases, so your eye becomes a little bit thinner. Okay, and shortening of eyeball. So your eyeball is shortened so that the rays are now forming behind your retina, so retina is not getting enough light to focus it, right? So these are the two main reasons, right? So your eye lens is now weaker, so you have to increase the power of the eye to correct this vision, right? So what you have to do, you have to use that u is minus 25 centimeter. Why minus? U is always minus. Now V is minus 75. Now this is interesting that basically he can see objects from 75 centimeter. So if an object is placed at 25 centimeter, that effective distance for eye should be 75 centimeter. So your eye will think that the object is actually located at 75 centimeter, so that your eye can make that adjustment and correct this defect, right? So this is the way to do it. So u is minus 75, because it's a virtual image, it will also be 75 centimeter. So you have to calculate what is the focal length. So focal length is coming out to be 37.5 centimeter, and power of the lens is coming out to be 2.67 diopter. Okay, so for all the parts you get 0.5, 0.5, 0.5. Okay, so as you can see, this is a convex lens because the power is positive, focal length is positive. So this is a convex lens. Okay, now the OR question, let's see the OR question. The focal length of the eye lens cannot decrease below a certain minimum limit. As a result, the sharp image of the object is not formed on the retina but behind the retina of the lens. So why we cannot see objects at a distance less than 25 centimeter? Maybe you can see, but it is not always possible, because main reason is that our eye lens cannot be contracted beyond certain limit easily. Okay, if you put too much force on your eye, that's why it is said that when you are reading a book, you should keep at least 25 centimeter distance from your eye. Because if you keep your book closer than 25 centimeter, like some people have a tendency to read the book from very close, very up close. So what happens is that your eye getting stressed too much. Okay, because of that stress, what happens in a long run, your eye will be getting weaker and weaker, and soon you will lose your ability to read objects. Okay, you will lose the ability to focus objects. Okay, your eyes will be weaker, and soon you will not be able to see anything without glasses. Okay, it can result hypermetropia, it can result myopia, but that will be almost a permanent damage to your eye. Okay, so never ever read objects, anything, your mobile phone, your devices, do not watch from very close to your eye. Keep a safe distance, always keep a safe distance. That will protect your eye, and you can see longer without wearing glasses, or if you are wearing glasses, you can see longer without changing your power. Okay, so this is the main advice for doctors. Now this is a recombination of white light. We can see that white light is getting dispersed into 7 colors, and then again if you put another prism in the opposite direction, inverted direction, this inverted prism will recombine the colors again and back to white light. So this is the recombination experiment, recombination diagram, right? The necessary condition for the formation of rainbows are the presence of water droplets in the atmosphere, and the sun must be at the back of the observer. That is, the observer must stand with his back towards the sun. So these are the two things. First of all, there should be water vapor present in the atmosphere, and the sun should be behind the back of the observer. So basically you are standing like that, and the sun should be behind you. Okay, not top, not front, it should be behind you and pretty below. Okay, that's why we generally see rainbow in during the afternoons, okay, evenings, just before sun's set. Why? Because sun is just above a very low angle, so critical angle is possible. You will learn about the critical angle etc. in your next class, but that is these two are the main conditions. Now 4-marker case study based question. So Rahima was investigating a circuit for her school project. She wanted to demonstrate the effect of length on the resistance of a conductor. The following is a given circuit with resistors A and B that are made of the same metal and the same thickness, but A is twice as long as B. So there are two conductors, one is A1, one is A, one is B. two conductors are there, okay, and it is also mentioned that A is twice long as B, okay. So A is twice, so if the length of this, say B is L, then A is 2L, okay, the length in terms of length, twice as long as the B, okay. The total current in the circuit is 6 ampere, the voltage is 12 volt, so voltage is given 12 volt, the total current is given 6 ampere, okay. What will be the resistance of the circuit 1? So what is the resistance of the circuit 1? You have to first calculate the resistance of the circuit 1, determine the value of RA and RB, so you have to calculate the resistance RA and RB, okay. So first of all, suppose you assume that RB is R, represented by R. Let me take a value which students most often resonate with. So say that RB is equals to X, okay, X value. So RA will be 2X. Why? Because the length of RA is twice. So we know that R is equal to rho L by A. So twice the length means twice the resistance as well. So if this is X, this will be 2X. Right, now they are in parallel combination, so in parallel combination we know that 2x into x divided by 2x plus x, right, so that is 2x square divided by 3x, so that is 2x by 3. So 2x by 3 is the equivalent resistance. The current is given, the voltage is given, the current is given, so we know that V is equal to IR, so 12 into 6, 12 equals to 6 into the equivalent resistance, right, 4x, so x equals to 3. Right, so x equals to 3 means RB equals to 3 and RA equals to 6 ohm. So you can calculate it like this, okay. RA, RB is calculated, the resistance of the circuit is calculated, okay. Resistance of the circuit is R equivalent, that is R equivalent is basically 2 into 3 divided by 3, that is 2 ohm. So resistance of the circuit is 2 ohm. Resistance of RA, RB is calculated 3 ohm and 6 ohm. Even it is too much overcrowded, don't worry, I will give you the solution in a while, just trying to explain it to you. Determine the current in the both ammeters. Will the current in A1 and A2 be the same? Justify your answer, okay. Or define resistivity, what is the factors affecting the resistivity of the conductor. So this is for the only C part. There is our question, so let's see the answer. So resistance of the circuit is basically you can directly calculate V by I, that is 2 ohm, okay, and RA and RB they have done a different method, okay, but this method is okay if you know it. Otherwise, if you don't know it, the method that I have shown you, calculate using equivalent resistance, that you have to assume that the this resistance is X, this is 2X, so equivalent resistance is 2x by 3. So using that you can calculate it, RA and RB to be 6 ohm and 3 ohm. For the given circuit, R is proportional to L, okay, and R is okay. So they have tried to give you some explanation about the current, but which I feel is not super cool. So what we know, that we have already calculated RA, RB, right? So we have already calculated RA and RB, and we are trying to find current A1 and A2, and they are connected in parallel, right, with a battery of 12 volt. This was the circuit, right? If I am not mistaken, A1, okay. So what we have to do, we have calculated that this one is 6 ohm, this one is 3 ohm. So they have done some explanation in the question of this part, which is I feel is not required. You can ignore this explanation part. So what we are going to do, that they are connected in parallel. They are connected in parallel means what is the potential difference across the resistances? parallel combination means potential difference across all these resistances will be same as the supplied voltage, that is 12 volt, right? So both of these resistances will have the same voltage. So current IA, that is A1, current A1, IA1 is basically voltage divided by resistance. So voltage is 12 divided by resistance, that is 2 ampere, and IA2 is basically voltage will be same divided by resistance, that is 3, that is 4 ampere. So 2 ampere and 4 ampere is the answer. Okay, that no explanation is required. Only thing that you have to mention that the resistances are connected in parallel and the voltage across them is 12 volt. That's it. If you mention that, you can apply this law and you can find the currents. Okay, the resistivity is defined as the electrical resistance of a conductor of unit cross-sectional area and unit length. So obviously the definition of resistivity, if you remember, we have discussed it in the past, that R is equal to rho L by A, right? So rho is basically R into A divided by L. Okay, so if we make A equals to 1, L equals to 1, then rho will be equals to R. So the resistance of a wire having unit cross section and unit length is the resistivity. So resistivity means you make the area unit, you make the length unit, whatever resistance of the wire, that is the resistivity of that wire. Okay, so resistivity is defined as the electrical resistance of a conductor of unit cross sectional area and unit length. Unit means 1. Unit means 1, right? So now it is the characteristic property of the material and depends on the nature of the material. So resistivity does not depend on length or area of the material. It depends on the nature of the material and temperature. And temperature is another factor that on which resistivity depends. Okay, it does not depend on the how long it is, how long the conductor, what is the area of the conductor. Resistance depends on them, but resistivity does not. Resistivity is a constant for a material, right? So it depends only on temperature and it depends on the material. So for example, maybe copper has a low resistivity compared to say iron. Okay, so if you change the copper wire using an iron wire, resistivity will change, resistance will change. But if you are using a copper wire of say very thick copper wire and a very thin copper wire, both will have the same resistivity, so it will be independent on that, right? Okay, so this is the end of this class today. And if you are currently studying in class 10th of any board, okay, and you want to check what is the best for you, what is the best future for you, and you are still not sure, this is also a message to the parents that don't forget to register for DSAT, that is Diksha Scholastic Aptitude Test, which is being conducted in our Diksha campuses every Sunday. So here you will be given a guided special tour about what is the possibility of your kid, or if you are a student, what is the best suited for you in future. So here will be a 60-minute lecture and a doubt clearing session. After the lecture there will be a small aptitude test based on the lecture, and based on the performance of your lecture there will be a one-on-one counselor who will guide you that okay, maybe even if you are thinking that you are very weak, actually you can prepare for NEET to take admission in the one of the best colleges of doctor, to become a doctor, right? So these are the career advice that our counselors will give you based on your performance in the exam. So how well you are performing, that is the key to your success, right? And I will be back with sample paper 6 day after tomorrow. Till then, bye.